Okay. So, hello everyone. Good evening. My name is Architect Guneet Singh, and we have gathered here for a session by the topic Building Energy Efficiency, a vision towards net zero to positive energy buildings. We'll be coming up with all the session through engineer Mani Khanna. Mani Khanna is BEE certified ECBC master trainer, green rating for integrated habitat assessment certified professional, Indian Green Building Council and accredited professional, and green and eco-friendly movement certified professional, and solar PV TOT certified trainer. He is working in Energy Conservation Division of Punjab Energy Development Agency, Chandigarh, handling projects related to energy efficiency in buildings. He is extensively involved in carrying out all activities related to the implementation and enforcement of ECBC in commercial and residential buildings in state of Punjab in coordination with stakeholder development and Bureau of Energy Efficiency, Ministry of Power, Government of India. He is graduated in mechanical engineering from Kurukshetra University and has done his PG in environment and sustainable development for Delhi University. He has more than 7 years of experience in working on green building, ECBC, building commissioning, energy and daylight simulation for national and international projects and other building energy efficiency projects. He has involved in carrying out successful green building projects with providing quality documentations and helped in carrying out facilitation of GRIHA, ECBC, LEED, GEM, EDGE certifications, and other code compliance projects. He has organized more than 80 capacity building training programs on building energy efficiency and involved as ECBC master trainer in more than 40 training programs across India. He is also solar PV trainer of trainers certified trainer for SCGJ, which is Skills Council for Green Jobs. He is associated with many societies like ASHRAE, ISHRAE, FSAI, IAE, MP, IBPSA, India, IPA. He is one of the founding members of IBPSA, which is for India chapter. He is serving extensive roles as zonal chair, North Youth at ISHRAE headquarters, YEA chair in ASHRAE India chapter, secretary ASHRAE Chandigarh chapter, CWC member, FSAI Chandigarh sub chapter, life member in Indian Plumbing Association, etc. So, taking up not to take up much of the time, I'll just hand over the mic to Maniji, so he can just start off with this session. In
Right.
the so I'll just point out one thing that during or after the session, I would request everybody to just write down their questions or their inquiries, whatever you have, so we can take up the questions in the end of this session. So please, Maniji, carry on.
Yeah. Thank you very much, Gunitji, for your brief introduction and having a great session with all of the architect fraternity and all building industry professionals. So, majorly our topic, welcome everyone. So, we have a topic today is all about the buildings energy efficiency. Buildings energy efficiency, a vision towards net zero to positive energy building. So we are talking about ECBC, we are talking about green buildings, we are talking about net zero and a vision to achieve within the next 5 years, 10 years. The target is to convert the building into net positive building. So this is the discussion and which is a great topic and I'm sure everyone will like as being an architect and being an engineer, everybody who is interested and who is involved in the building industry. So these all are relevant respective to sustainability in buildings as we all see in the scenario right now. So we all know we are battling the virus these days. So there is no mass gathering is allowed. So that's why we are doing this session digitally, and it is great connect by Mr. Guneet Singh. So this is the basically hand sanitizer, how to maintain social distancing using masks, and to create a new era of technology which is completely going live. So, what is the importance of sustainable development in this time and in this era about requirement of the sustainable building, sustainable development? What are all interventions required for net zero building? Why energy efficient buildings? And what are advantages for net zero positive and net zero energy and net zero positive energy building in the cities that we are going to develop in the times to come, in our areas, in the urban areas, that the buildings we are going to design and construct, that we need to take some of the action and need to take a very integrative type approach so that we can integrate our energy efficiency and green building in our upcoming design and construction. So before directly jumping to the topic, I would like to briefly touch upon some of the facts which we all must aware about it. So these are some of the facts, like impacts of the global warming. So we are seeing how the climate is changing, how the global warming is impacting, and how it is creating impact to the environment. Another is the rising sea level, how the coastal flooding is coming up, how the frequent severe storms, sometimes you have seen, so during the summertime, summer season, so we are able to see the frequent severe storms that we are able to capture our environment. Another is the melting glaciers. So the
Uh,
glaciers are melting these days, and it is a well accepted news which have been floated by the many news channels during the winter season in month of January or February, where we are seeing that the glaciers were melting at that time, and how it is very critical to our environment and how it is creating impact to the environment. Another,
Maniji, I'll just pinpoint. People are saying that your voice is slightly lesser audible. There is some disturbance. So can you please raise your voice for a while?
voice, I am sure that could be right now. So is it correct? So is it audible to you completely now?
Yeah. Okay.
Okay. So yeah, basically, unprecedented snowfall, the major another impact to the environment, that is the unprecedented snowfall. So that area where we haven't seen the rainfall in last last 10 years, 5 years, 15 years, where we have not seen the rainfall, like in the Missouri, or like in the areas like Kasoli. So in the down part area where we haven't seen that how the things are changing, and how the unprecedented snowfall we have seen in last of the times. Another is the excessive rainfall and floods. कि रेनफॉल एंड फ्लड्स में हम कैसे हमने देखा कि लास्ट इन एरियाज लाइक केरला and Srinagar. So we have seen in last 2 years there is excessive rainfall and floods that we are able to see. So that creates a great impact to our environment, and how the rainfall and floods creating something bad to the environment. Yeah. So the another is the burning of crops. So I'm sure you all have seen the news which we were listening in the Haryana and Punjab area, where the crops are burning, and how it's creating bad impact to the environment. So another is the no voice. So there is a message. I'm sure now the voice is clear. Yeah, yeah. Maybe I can switch off the video so
Now
that I
it
can
is
attach
better.
it. Yeah, yeah. Okay. So majorly the destructive wildfire as well. So this is the another impacting another situation that is creating bad impact to the environment, because what we are doing, what we are destroying our natural land, natural areas. We are cutting our trees, and we are creating impact something bad to the environment. Another is the pollution from thermal power plants. So there is another environmental impact, which is the pollution which is being created by the thermal power plant from where the power is being generated. And we are majorly dependent upon 70% of all resources, which is, yeah, we are generated through this thermal power plants. Another is the burning of waste and crackers. So we can see how the burning of waste and crackers during the Diwali season. We all know we are circulating a message like go green and celebrate green Diwali and no use of crackers. So these burning of waste and crackers. uh, So yeah, so this is another impact which is environment creating bad impact to the environment. Another is the intense heat wave. Intense heat waves means so like as you can see the temperature outside. So what is was the temperature 5 years back? It was around 35 to 38. And how the temperature of outside air condition is changing day by day. So these days we can see the temperature is increasing and the relative humidity is also increasing. And the temperature even goes up to 45, 48 degrees Celsius. And even humidity in the urban areas where we all people live in the cities and the humidity even goes more than 90% in our areas. So there is a more intense heat wave. Another is extreme drought condition. So we know there are there are areas in our country where there is not enough supply of water and acute water shortage we can see in our urban and rural areas. Even this type of situation we can see in big major metro cities like Delhi, Bombay, Bangalore, where we can see there is a water stress by 2040. We can see, and very soon after 10 years. So these days, a building is one of the challenge. How we are converting our buildings to energy efficient, green buildings. So there is another challenge that is coming, parking in next 2 to 3 years. The parking in next another 2 years, we are a major challenge to converting to smart cities because everything is now going digital. And to make cities as smart cities, we need to improve our infrastructure. We need to improve our connectivity. We need to improve our parking spaces. We need to improve our infrastructure. We need to improve our connectivity. So these are the another challenges that we are seeing and forcing in the next 4 to 5 years. And after 10 years, definitely you will see there is a water stress. There is another major challenge. Water stress by 2040, we can see. Another is the increase in extreme weather events is felt everywhere. We can see the blackout in 2011. There was a complete blackout when there was no electricity and complete North grid has been failed. So these are the failures that we need to overcome and look after so that we can focus our attention into the energy efficiency, green buildings, and the sustainability part. Another major challenge is the emission of CO2. That is a major cause of global warming. Emission of CO2 is a carbon emission in the environment. So you can see the carbon emission, it is just in 130 years, it has been increased by more than 45%. So this is another major challenge because we are using the air conditioner day by day. We are increasing our usability and requirement of air conditioner. We are increasing our transport by using individual cars, by individual people at home, individual air conditioner, even people live at each and every room. So there is another challenge which is emission of carbon emissions, which creates a major cause of the global warming. Another is the air pollution. So I've seen you, there's a major challenges that these days we are focusing about. Air pollution, you can see Kanpur and Delhi among the 15 worst cities in India, and Mumbai being the fourth most polluted mega city. That study considered under PM 2.5 and PM 10. PM 2.5 एक लेवल है, एक इंडिकेटर है जहां से हम अपने एयर क्वालिटी को मेजर कर सकते हैं और चेक कर सकते हैं. That is the adjustable or that is convenient to us or not. That air quality that we are taking in and we are breathing, even we are at outside, when there is a air quality we need to check. There is a parameter like PM 2.5 and PM 10. So these are the cities, Mumbai being the fourth most polluted and confident Delhi among the 15 worst cities in India in top air pollution. So that is a study considered by Times of India even. Another, you can see the impact of air pollution. You can see one of the metro cities. This is an example from Delhi only. So you can see how the air quality is changing, our environment, how we are breathing the air, which is not being cleaned, which is not being pure in nature. So we always in the month of November and December, we always see a word. There's a buzzword like smoke. So few days back and few years back, we were listening about a word called fog only. So fog is, we all know, that is due to the low dew point in the atmosphere. That is a fog which we can see in our environment. But when there is a smoke and fog, then there is a combination. We are discussing about smoke these days. So smoke is one of the criteria and parameter where we are listening, and that is only due to the air pollution. So smoke is majorly due to the pollution from industries, pollution from buildings, pollution from the transport. So that is all. So you can see what is the environmental effect of coronavirus. So we are living these days, and we can see how the coronavirus gave us a great impact, what environment gave to us, and how we need to protect it. There is another major question: what environment is giving to us, what environment is giving to us, and how we are taking back, and what we are providing support, and what we are providing back to the environment. So there is a clearer water and cleaner air. These are the environmental effects of the coronavirus. So you can think here. Yeah.
Maniji, again, people are saying that your voice is a little bit not audible. Can you please raise your voice? They
Oh,
are
yeah.
appreciating the presentation a lot,
Yeah.
but they are saying कि voice बहुत कम आ रही है. Please raise
आपको
your
आ रही है
voice.
सर आवाज पूरी?
थोड़ी
आप
थोड़ा सा हल्का सा जो है ना उसको थोड़ा सा टोन कस कर दो.
एक मिनट. ओके. Uh, yeah. Now is it better?
Uh,
Yeah.
I suppose.
Now,
I
right.
Yes, yes. People are saying yes. Okay, fine.
Okay. So there is a question that we need to think upon. What coronavirus, what COVID-19? So there are some again words that we are hearing and listening these days only. And before coronavirus, you can see the condition. So this is again one such example from great place in India, one of the great place which is before coronavirus. How was the condition of air quality? Because when every building was running, every industries were running, every industries were running, every transport was running, every buildings were operational, everything when there was a running in and operational condition. And what is the yeah, and what is the condition before coronavirus and after coronavirus? You can see when everyone was at home, no transport, no buildings were operational. So there is a question that we need to give something back to the environment, because we are taking something from the environment day by day on a daily basis. We are running air conditioner. We are constructing new buildings day by day. We are destroying our natural lands. We are converting to the more operational condition, more buildings. So everything is operational. Everything is we are taking. So we need to give something back to the environment. There is a question. So you can see the environment around us during this time, how the nature breathes again, how the nature breathes again, how the air quality have been improved, how we can breathe the air very easily and very good for our health even. So see the environment around us. So these are the lockdown effect, the coronavirus impact. You can see in Delhi only, if you can compare, which is one of the major metro cities and nearest to our place. And Delhi, when you can compare it with November to March 22, November to March 22, you can see how the air quality have been improved. And after 22nd March, when 23rd March even, on a single day when there was a complete curfew condition on 22nd March. So I am sure you have seen that condition. On 22nd to 23rd, more than 40% of the air quality have been improved. And if you can compare it with November to March, definitely you can see more than 60%, 70% air quality have been improved in our cities and metro cities. So that is a major positive impact. And this is a vision to create a peaceful and sustainable earth that will give us strength for the future. So that is a vision that we need to create. So this was my overview. So now we are proceeding. What do we need to know? Do you know about it? Yeah, do you know about it? I request everyone to please keep your mic on mute, please. Yeah. So there's a Greenland. What is Greenland? When we were living around a complete green area around us and green native plants, trees, landscaping, everything when there were around us, and we were able to breathe clean air, and we were able to have a fresh air even from the outside. How we are converting our natural land to the man-made land. So there is a concrete jungles. So there is a concrete jungle we are going to convert. So this is the main thing, that how we are improving and how we are changing our sustainable architecture to the man-made architecture or the concrete jungles that we are going to develop. So green worries there are green worries. So cities are facing challenges of providing higher level of comforts, because you all know, as an architect, as an engineer, you all know what is the our thermal comfort temperature. Thermal comfort range is in between 22 to 27 degrees Celsius. So if the outside air conditioned temperature is changing day by day, if it is increasing 40 degree, 45, 48, how we need to meet our comfort requirement, thermal comfort requirement, so that we will not able to increase the energy consumption, so that we were not able to increase our increasing demands of all type of resources, that is energy, water, waste, healthier space for occupants, indoor air quality. So there are many things that we need to focus upon. So but because all buildings are responsible for 40% of carbon emission, please note this line: buildings are responsible for 40% of carbon emission, 30% of the solid waste generation, and 20% of the water effluents. So these are the major resources that is caused by the buildings only. And the changing trends are there. So first is growth in economy. Second is the advancement in technology. And third is the emerging lifestyle. How the technology is advancing day by day. You can even see in the lighting technology and air conditioner. We were not using air conditioner when there was no such requirement. And even if we have one air conditioner at our home, we usually try to adjust it one room only. We usually try to adjust it in one room only. But when there was a lifestyle is changing, when there is a emerging lifestyle we have seen, when we were try to able to sit in a car, we actually try to first run on the air conditioner, and then we actually accelerate the car. So how you can see our changing lifestyle. So what corona and what impact, another major impact have been given by the corona. So everyone, even at home, they usually try to sit and stay, even individual at their own rooms, so that they are more reluctant to use natural ventilation or fresh air, but they are more adaptable to use air conditioner. And there is a increase in air conditioning demand. And when there was 5 years back, there was no such rating system mandatory. And just 2 3 years back, there was rating system mandatory. Then again, new technology were coming up: 2 star, 3 star, 4 star, 5 star. And now these days, even inverter air conditioner. Then you can see dual inverter air conditioner. And now these days, with the sensor-based technology, when everyone is at room, then AC will run. AC will be operational. When we left the room, after 30 seconds, it will automatically switched off. So you can see the technology in last 5 years how it has been increasing. So same in the lighting part, same in the another water efficiency, same is the indoor air quality. You can see the air purifiers are coming up. So when you see during the water, during the COVID time, so the sanitizers, demand of sanitizers is increasing. And when you not try to use it through hands, so there is again mechanical hand sanitizer also coming up. So you can see the technology is increasing day by day. But another challenge we have, what we are able to see. So what is the context of our cities? So we are developing such type of building. We are developing these buildings. This is one such example from nearest metro city like Delhi, Gurgaon. So the building we have designed and constructed is completely glass buildings. So you can see why we are putting glass. We need to capture natural daylight. So that is the objective only. Why we are putting glass? Because of to capture natural daylight. But you can see during the daytime, more than 90% of the glass is covered with the curtain. So what is the objective of putting glass so much? So if 90% of the glass is covered with curtains, and if the air condition, if the complete glass facade is also increasing heat gain to also interior part of the building. So to remove that heat gain, you will also run the air conditioner. So when air conditioner will run, so it will also increase your energy bills. So overall building more stuff. So you can think upon the logically. So you all being an architect and being an engineer, you all think logically how we are discussing and how we are designing our current scenario, buildings part, the design concepts, the construction concepts. So overall, first is the glass cost, then curtains cost, then air conditioners cost, then again when there is a more requirement to run air conditioner, then more energy bills is increasing. So overall, there is a much demand over the electricity grid also. So we need to think logically. So there is another question. The we are individual rooms, individual air conditioner we are providing. So we are increasing our building demand load. So there is a more increase in demand in energy consumption if we are running air conditioner in each and every room individually. So right, these are the questions that we need to discuss. And another part is again the Delhi NCR. If we are from the composite climate like Punjab, Haryana, Delhi, so I am showing you the example why we are designing such buildings and how we need to think upon it, and we need to integrate better part. Delhi NCR, Mumbai, again being the different climate, all tall buildings, glass buildings. Kolkata, again different climate, all tall buildings, glass buildings that we are developing. Do you think this is responsible for our climatic condition? If these are the Western architecture, if these are copy pasted architecture designs, then how we need to accept in our climatic condition? Because our climate is more increasing like 45, 48, even it is increasing more, and also the humidity is also increasing day by day. So we need to think upon it. And you can see here what is the breakdown of energy consumption. Total electricity consumption, out of which 33% is consumed in buildings, out of which 24% is consumed in domestic, and 9% is consumed in the commercial part. So total 33% is consumed in the buildings only. And in the buildings, if you will bifurcate all the appliances, so you can see here, lighting consumes 59%. अगर आपकी बिल्डिंग 100 यूनिट टोटल कंज्यूम करती है, उसमें से 59 यूनिट्स इज द लाइटिंग कंजप्शन and 31 units is the air conditioning consumption and 10% is the another miscellaneous equipment. So you can see here the commercial buildings like hotels, malls, hospitals, all government building, commercial buildings, every such hospital building like IT building, all such types of buildings are is coming up. You can see here the year 2017, 1.4 billion square meter has been constructed. By 2037, it is going to construct more than 35% area is still yet to be constructed. It means around 2.2 billion square meter is going to be constructed by the year 2037. So there is a huge demand, huge building sector is coming up, huge commercial buildings are coming up, and the India's energy consumption amounts to 700 billion units of electricity. 1 billion square meter of area is yet to be constructed by 2030 only. So in just 10 years, you can see 1 billion square meter, which is huge. We need to think upon. Energy efficient design and construction can save you up to 50% of energy. You will not believe, I'll show you in my example. So net zero energy building, net positive energy buildings are coming up, which is more than 50% energy savings also. There is energy code scenario. You can see this is a huge potential of energy saving, and because of that, many of the countries across the globe have created such energy codes, and these energy codes are well accepted by many of the countries, and some of the countries have created those as mandatory approach. So you can see here more than 50% of the area have been constructed and designed the building as a mandatory approach to save energy, because the potential is huge and the market is coming up. Voluntary approach, you can see voluntary approach in India. You can see here the blue light blue part where it is showing the voluntary approach, because in some of the states it is already been mandatory, and some of the states it is going to be mandatory. Another is the mixed approach. Like I'm just starting from ECBC now. ECBC to green buildings, to net zero, and to net positive buildings. So this is the vision for the next upcoming slide. ECBC, Energy Conservation Building Code. So it is designed as per the EC Act 2001. There was an EC Act which was developed by Ministry of Power, and this code was launched in May 2007. So you can see more than 13 years have been passed away when ECBC for the commercial building have been came up. So the buildings and energy efficiency have started from 2007. So that ECBC have been launched by Bureau, which is under Ministry of Power, and further it is going to accepted by the states as per the state requirement. So we have seen and we have discussed what all states are required. So what all states have different climatic conditions. All states have different types of buildings. All states have different type of the temperature requirements, different type of scope of the building. Few of the states having major buildings which are having more than 50 kilowatt, 70 kilowatt, right? So all these states have amended this code and then notified in their government gadget notification and made them as a mandatory approach for ECBC in all commercial buildings. ECBC is applicable to all buildings which are having connected load 100 kilowatt, contract demand 120 kVA, and conditioned area 500 meters square. So that is a huge. So you can see the buildings like hotels, hospitals, malls, office building, government building, private building, IT parks, and the major uh, uh, multi-family residential buildings. So that are coming up, that all comes under the purview of ECBC. So there is a commercial buildings, there are office buildings, educational buildings. So these are all that I've already discussed. So these all are covered under ECBC. ECBC amended states, more than 20 states where it has been amended. So you all being an architect and engineer have heard about the code is NBC, National Building Code of India. So that is again a voluntary code. It is a big like Granth book where you can see the uh, every type of facilities like fire, architecture, electrical, green, sustainability, mechanical, all such types of plumbing. So all such types of various requirements have been incorporated in one code only. But it is not mandatory. That is a guideline also. ECBC is there are 20 states which is going to mandatory, and very soon it is going to mandatory in each and every state in the country, in India in seven. So that is the ECBC which is for commercial. So states which they have accepted, they have amended, and then they have notified as a mandatory approach. Punjab, Haryana, Karnataka, Rajasthan, every type of states. So these are the state I've mentioned you here. So they all have mandatory notified and made them implemented. जब भी आपका कोई building plan, when there is a past, when any building plan will be approved, it will be approved with the purview of the ECBC only. So when that ECBC 2007 was launched, again Ministry of Power, Bureau of Energy Efficiency have launched ECBC 2017. So that is a vision of creating net zero energy building. So ECBC 2017 is a vision towards net zero, responds to the changes in building technology, energy saving, mandatory implementation. So you can see here ECBC 2017, the components are building envelope, comfort system, lighting, and electric and renewable. Only four parameters are just going to consider in ECBC 2017. All four parameters, just four parameters. So yeah, these are the technology neutral code. These are renewable energy integration. So when there is a complete energy consumption of your building would be offsetted by the passive design strategies incorporated with the renewable, and it is technology advancement integration for your building would be ECBC. You can see here, India is completely divided into five climatic zones: hot and dry, warm and humid, composite, temperate, and cold. So there are five types of climatic conditions. Yeah. So you can see here. So Punjab and Haryana, Delhi is comes under composite. Himachal, all area J&K, Himachal and Jammu and Kashmir is comes under cold climate. Gujarat being the hot and dry. Rajasthan being hot and dry is the Rajasthan. Warm and humid is the Gujarat. And the temperate, which comes under Hyderabad, Bangalore, and the some part which is covered in the southern region. What is the impacts of ECBC? So it is already divided into three categories. Super ECBC is majorly, it is a target to create net zero energy building. So super ECBC is just equivalent. I'll show you in my upcoming slide. So when you will save, when you will create a ECBC building, you can save up to 30%. When ECBC plus buildings, you can save up to 40%. And you can save, create energy efficiency by 50% by creating super ECBC building. And to create 50% to above 50% when energy used is 50% and energy energy produced is equivalent to the energy used, it is equal to net zero energy building. So you can see here what is the vision from ECBC to green to net zero. And if here you can see, if the energy used is 100 and energy produced is 102, 102. If energy used is 100 unit and energy produced is 102 units, so it means your building is net positive. So this is how we are going to discuss. ECBC for residential building is also coming up. ECBC residential buildings are also coming, which is creating a huge impact because major market where there is 60%, 70% growth in the residential sector. So this code first part of building envelope have been launched in 2018, December 14 December 2018. They have launched by the Ministry of Power and Bureau of Energy Efficiency. The code name is Eco Niwas Samhita. That is ECBCR, ECBC residential. So 125 billion units of electricity per year you can save by 2030. So 125 billion units of electricity. So this is creating a major impact in the building industry. You will not believe building sector is increasing. You can see by 2016, if you can compare it with 2031, in just 15 years, it is going to be increased by more than the 4 times the building energy consumption, residential electricity consumption, more than 4 times, which is huge. Another is what are the design intervention for net zero to positive building? Net zero to positive, ECBC, green, net zero, positive, everything will be covered. So you can see here the design from starting from the top left is the highly insulated envelope, highly insulated envelope, and you can start from the clockwise, highly insulated, heat recovery ventilation to restrict heat directly that is inside, solar thermal panels, night flush. Night flush means when there is a जब आपका गर्मियों में या सर्दियों में जैसे भी आपका जो टेम्परेचर during the night time when the temperature is lower and you can open all of your windows and it will directly the fresh air and the cool air is directly coming up to the interior part of the building and your completely building is cooled, not air conditioner, your building is cooled, so that is the night flush. Thermal mass, shared facilities, district cooling system, when there is a all centralized air conditioning system at one place and you can provide cooling to the complete building at one time. Major open spaces, you can see the green, you can see the grass, you can see the green part, you can see the grass part, you can see the major intervention that is required, landscaping. Another is the lowered operable shadings in respect of in addition to window wall ratio, how you can operate it lowered operable shading windows, natural ventilation, uh, natural ventilation we have irrespective in addition, yeah,
Hello.
yes. So yeah, basically in addition to it water conservation,
So,
yeah, please keep your mic on mute please.
so can you please explain the night flush system again?
Yeah, hello,
Hello.
yes.
So can you please tell about the night flush system again?
Yes, night flushes, you need to have the windows which are operable, which are openable windows. So when there was a temperature, when during the daytime, you can see the maximum peak temperature during the daytime is 45, even 48. But when you can compare it with the nighttime temperature at 9 p.m. at 10 p.m., when there is a lower temperature outside. So then you have around 30 degrees Celsius. There is a temperature, right? So 30 degrees Celsius. When your temperature is 30 degree, even at outside during the night time, you can open all of your windows and you can have the fresh cool air that is coming inside our building, and when it is going to circulate inside part of our building, it will automatically be night flush. It will be air cooled. The building completely will be air cooled. That is the night flush technology. It is a simple term. When at the night time, when the temperature is less, you can open your windows and allow that cool air to enter inside our building, and it can circulate inside part of our building, so that it can use it can lower down the temperature of our internal part of our building. Another is the hydronic heat and water conservation. So these are all such type of parameter. When we integrate very logically all such type of parameter, depending upon our cost, depending upon our design, and depending upon our implementation, definitely all our buildings will be net zero to net positive very soon. So yeah, these are the design intervention for net zero to positive. So first type of the comparison, first parameter is the orientation. How you will set your orientation. Then your wall assemblies, brick wall, cavity wall, AAC wall, brick wall with insulation, and the RCC wall. So these are all type of assembly of wall assembly. How we are constructing our walls, how we are reducing our heat impact adding to the environment. Another is window size. We need to concentrate upon it. We need not to construct complete glass buildings, because glass buildings or the more than 90 path. So sun path, how the sun heat is directly impacting to the interior part. So we need to have 40% window wall ratio with a proper shading devices. So window wall ratio and the wall assemblies, all wall roof assemblies, that U value. U value means thermal conductance. How much outside heat is traveling to the interior part. If maximum heat is reduced, then it means U value is less. जितनी U value कम होगी उतनी बाहर की गर्म हीट अंदर कम आएगी. So it means we need to have U value as minimum as possible. So we need to integrate like cavity wall and AAC wall and brick wall with insulation. In addition to it, we can use the glass, which is 40% to window wall ratio, with a certain shading devices. In addition, we can use the types of glazing. In addition, we can use the type of glazings, which is single glaze and double glaze. It is not mandatory to use double glaze. We can even use single glaze with the shading devices. If there is no shading, but I would directly recommend, you can provide shading devices to the south and west part, which are major heat ingressive areas. So double glazing, which is also reducing and which restrict allowing heat to interior part of our buildings. Another is the doors and windows. We need to have a color, a vision, a single glazing or double glazing. We need to choose in such a way that the VLT, visible light transmitter, whatever the light is available in the environment, whatever the light is available in the environment, we need to capture it through glass and the doors and windows. We need to capture minimum 30% VLT should be there. Improve daylighting. Daylighting is, if we are putting glass, If we are putting 40% glass even, we need to put glass very logical point, because a glass is a major heat intensive area from where direct solar heat gain is directly impacting to the interior part of your building. So improved daylighting means you must have the VLT 30%. You must need to select glass which are which having VLT is good and which can improve our daylighting, like blue glass, like green glass, like with tinted glass. So that we need to use, which is also helping to improve the daylighting. Another parameter is to improve our thermal comfort conditions. So we all know our thermal comfort requirement is 24 to 27 degree Celsius. And if the outside air condition temperature is 45, how we need to integrate without air conditioners, and even with the air conditioner, how we need to set our thermal temperature, how we need to allow the natural air to allow the interior part of our building, how we need to design our building envelope that will improve our daylighting and create thermal comfort to our interior part, like improving natural ventilation that I've already discussed about. Another in the summer season, in the left part, limit heat gains, and in the winter part, limit heat loss. In addition to it, we also need to integrate with renewable energy systems. That is a major push. Renewable energy system that will also help you to provide to the shading of your roof, that will also help to generate your electricity, that will also help to reduce your connected load, and it will also compensate all your electricity consumption in your building, which would be offsetted by the energy generation from the solar panels. So green buildings are one which is providing efficient and economic use of all resources. To design and construct with the building having efficient and economic use of all resources in a building is a green building that covers energy, that covers water, materials, human health, and environment for entire life cycle of the building. Another is the building which is having less water, less energy, conserve natural waste, generates less waste, and provides healthier space for occupants. So that is a green building. So you can see here. Another impact which is environmental benefit, having social benefits, having economic benefits. Environmental benefits reduce air, improve air quality, improve water quality, reduce water streams, protect biodiversity, conserve natural resources. Social benefits, enhance occupant comfort, improve overall quality of the life, and economic benefit. It will reduce your operational cost, even at the energy part, water part, waste part, air quality part, every type of the systems which are using in our building, that all will be reduced. And government is also providing tax incentives and subsidies for the construction of green buildings and renewable energy concepts. So green building is one which is having carbon emission less 35, water use 40, energy use 50, and solid waste 70. Every type of glass classification, building, green classification, sorry. So green classification, every type of your building, like home, facilities, factories, new buildings, healthcare, township, campus, metro, cities, every type of classification can now be termed as a green building. So there are some recommended building material which I would like to highlight. First is the building insulation. You can put, there are various types of insulation are available. You can use it in wall, you can use it in roof, which can also restrict heat gain to interior part of your building. but is major impact building insulation. So there are various types of insulation. You can see here various insulation scenarios. Cavity wall with insulation. Cavity wall. You can use bricks. Many types of bricks are available. So you can see the bricks. So bricks like red bricks, fly ash bricks, perforated bricks, AAC blocks, hollow blocks, thermal insulated blocks. There are many types of materials are available. In addition to it, insulation various types: glass wool, rock wool, puff insulation, thermocol, EPS, XPS, styrofoam insulation, puff foam insulation, and puff spray insulation. So there are various types of insulation and bricks material which you can use, which you can develop your building assembly and restrict your heat to enter inside the building. So see here, if the building having wall is single wall, it allows more heat to enter inside the building. When there is a cavity wall, when there is double wall with insulation and is a thickness is more, there is a lower chances of heat enter inside the building. So there are some shading devices you can see on your screen. So horizontal overhangs, vertical fins, and there are many types of such devices where you can see here uh, the different type of shading devices which can provide natural light to enter inside the building, but it will restrict solar heat gain inside the building. So yeah, another is the roof part, how you are constructing your roof. In addition to brickbat, koba, or very conventional practices, what do you use? So you must use the buildings which are having RCC above and below deck. You must need to have the insulation part. In addition to it, you can use the white tiles or white paint on your roof so that your roof will be cool roof and it will allow less solar radiation to enter inside the building and which will impact less, because when you use white tiles or white paint, more than 90% of the solar radiation will be reflected back to the environment. So these are the glass, single glaze, double glaze, UPVC frames, high performance single glazing, high performance double glazing, even triple layer glass is also coming up. You can see the movable lowers, you can see the barriers, vertical overhangs. So these are major resources that we can see how we can use logically this fenestration area. We can reduce our complete glass building to artistic building. So why we are putting complete glass more than 90%? Simply because to give artistic look and time of construction is less. Here also you can see the fenestration provides light, ventilation, and the views, and it must connect with the nature, which is also a major requirement to increase our productivity. Glass is used extensively, so we need to reduce. We need to create building like that so that we can have recessed windows. We can reduce the use of windows, and we can create the shading devices as well, like such examples. Double glaze glass, you can design and construct in your building external shading, like at the external surface of your wall, mutual shading over the surfaces, over the adjacent floors, over the adjacent areas. You can have the mutual shadings, the lighting, LED lighting, solar lighting, street lighting, all types of systems if that are integration with occupancy sensors, motion sensors, astronomical time switch. There are many types of external and lighting resource. We need to integrate LED lighting with all such sensors so that when we enter in the room, it will automatically switch on. When we left the room, After 30 seconds, it will automatically switch off. We need to reduce our heat gain. We need to reduce the use of such buildings. We can create like this. This is also creative buildings. This is also good artistic building. These are also glass, but you can see the exposed glass is only in front of exposed areas. The areas which are the staircase, the which are storerooms, the which are washrooms, the which are storerooms, right? So that areas that must be exposed in front of the glass. All regularly occupied areas must be having glass with a shading device, and it is automatic shading device. When there is a requirement, and you can integrate, when you can cover it with the you can cover it with the shading device. When there is no requirement of shading, you can turn up, you can also turn up, so that when there is a better cloudy condition and better cool air is running outside, you can open your windows, you can you can heighten your operable device, and you can open your windows and have clean air and cool air to come enter inside the building, so that your building will be complete cooled. Another is the HVAC technologies, which are, I've already mentioned, which is also increasing, which is also uh, advancing day by day. So these are the all resources that we need to integrate. VRF chiller, district cooling, radiant cooling system, and geothermal cooling. So these are all such like radiant, like geothermal. These are known refrigerant type. So firstly, you try to design building which are using natural ventilation or evaporative cooling systems, which are not using direct air conditioner or refrigerant based systems. We need to use minimum B 3-star rated and minimum equipment efficiencies, and provide natural ventilation, and it must be integrated with automatic controls. If there are 40 rooms in a building, so you must connect with the VRV VRF. If there are a large building more than 2 lakh square feet, more than 3 lakh square feet, you can integrate chiller system, which is like the malls, that we usually, when we enter in the malls, we can get the air conditioner, and we can get the cooled air, conditioned air. And when we use the radiant cooling and geothermal cooling, these are all type of non refrigerant air conditioning systems. Radiant and geothermal, non refrigerant, it means it is also best to the environment, and it is also consuming less energy, which is the objective. ECBC components will help the reduce the cooling loads in the building. You can see the building, you can see the design, how the natural landscape, how the trees have been integrated, how the glass portion have been integrated, natural ventilation, complete such a way so that your building should be consuming less energy and consumes natural ventilation, and your building should be renewable energy integration. I am coming to the next slides, which are net zero to net positive, and renewable energy is the major focus, major integration, which is the main requirement, how we need to integrate, what is the cost, because 1 kilowatt solar PV can be installed on 100 square feet roof area. 1 kilowatt solar PV installation can be installed, but it is unshaded. That should not be shaded by the trees. That should not be shaded by the another adjacent floors, adjacent areas, adjacent buildings. But it should be unshaded area, 100 square feet area, 1 kilowatt installation, and 1 kilowatt installation, it can generate 4 to 5 units of electricity per day. 1 kilowatt installation, 4 to 5 units, another energy generation in your buildings. So this is another one such example, which is world's largest rooftop at Dera Byas, and this is a Sidwa Canal branch near yeah, another major part is the 2.5 yeah, 2.5 megawatt capacity canal rooftop. Another is the Parliament House, where it have been installed where there is a no shaded area. The trees were there was no adjacent area, there was no adjacent building, and the trees were very far away from the roof where the solar PV have been installed, and 80 kilowatt solar PV have been installed at Parliament House even in India. Green building rating systems. So Griha, GEM, IGBC and USGBC, four types of rating system in India is available. Griha is the association of Terry. GEM SOCHEM, GEM Green Building Rating System, Green and Eco-Friendly Movement. So this is one of the partner today for this webinar as well. So GEM is the Green and Eco-Friendly Movement. This is run by SOCHEM, and it is one of the rating system in India which is providing rating system from GEM 1 to GEM 5 over a specific requirements. Specific 32 requirements. If I'm not wrong, more than 32 requirements are there so that your building would be completely GEM certified. Same as with IGBC, same as with USGBC, certified silver, gold, platinum, they are providing. These are the rating levels. So GEM is providing GEM 1, GEM 2. Griha is providing 1 star, 2 star. Lead and IGBC is providing certified silver, gold, platinum. So these are the rating levels. So you can create your building as green building. You can get recognition. You can get your achievement. You can create your building, green building, and you can get your uh, uh, 5% extra FAR from the government, because government is also providing incentive and also encouraging architects and engineers to design and construct green buildings. So that is providing 30%, 40% energy, water save for 25%, extra FAR that is providing by the government, reduce operational cost by 19%, more occupant productivity, better market value of the projects, and it promotes the renewable energy. So this is how the we are vision towards ECBC to green and now to the net zero to positive energy building. So what is how the vision is creating achieving zero to positive? What is the old building that are conventional, that is completely using old technologies, 10 years back, 15 years back, 50 years back, how the buildings were designed and constructed. So another is the code minimum, that is ECBC. Code minimum requirements, ECBC requirements majorly. Another is the green buildings that I already discussed, green part, and above to it the net zero and the vision to positive energy building. Advancing net zero, you can see the roadmap is coming up. It is defined by the World Green Building Council. So there is a vision to create 100% of the buildings must operate at net zero carbon. You can see here the certification, corporate engagement, trainings, government, all 30 till 2030, all new buildings must operate at net zero carbon. All new buildings, you can see here, new buildings is new construction. The target is to create net zero till 2030, and till 2050, the target is to create 100% of the buildings operate at the net zero carbon, right? So this is the another you can see here how you are creating reduce energy demand, generates balance from the renewables. Like this, as I already discussed, whatever the energy consumed in your building, first your design, your building design like that, your building should be energy efficient. And after that, you design all your equipments like the HVAC, like the electrical, like the renewable. all such types of devices and instruments should be achieve 5-star rating system and integration with renewable energy system. Whatever all energy is being consumed by the 5-star rating devices, it will compensated by the energy being generated from the solar panels which are located at the rooftop of our building, even at the rooftop or even at the ground part. So this is the vision. This is to create net zero building. So the net zero to balance between all energy system and the renewable that I have just mentioned. Whatever the energy consumed, here the meter, you can see the energy meter here. So this is an analog, but now the digital meters, smart meters, and now they're coming up. You can see here high efficiency system, HVAC, daily advancement in technology is coming up. Lighting, appliances, all such appliances and all construction technologies, like all such type of materials that I have just mentioned you, all such type of material I have already described, and it must be compensated with the, so to bridge the balance between this high efficient systems and the solar electric and thermal system, here your building would be net zero energy building. So net zero you can see here. You net zero is the concept of the building generating their own energy needs by renewable. Whatever the energy is required by the instruments, by all appliances, it must be generated by the solar panels. आपकी बिल्डिंग की जितनी भी एनर्जी की रिक्वायरमेंट है, दैट इज कंपनसेटेड बाय द सोलर पैनल. उतना ही एनर्जी वो जनरेट कर रही है. दैट इज द नेट जीरो. If you are focused about the net positive means जितनी भी एनर्जी अगर आपकी जरूरत है, अगर आपकी 100 यूनिट्स जनरेट कर रही है, 100 यूनिट्स कंज्यूम कर रही है बिल्डिंग with all such types of instruments like 5-star air conditioner, 5-star fans, LED lightings, and the all such type of building materials like the double glazed glass and the uh, you can see the cavity wall with insulation. If all such instrument, all such, if total consume 100 kilowatt, अगर आपका सोलर पैनल भी 100 किलोवाट ही पर डे एनर्जी जनरेट कर रहा है, दैट इट मींस इट इज नेट जीरो. अगर आपका रिन्यूएबल 100 की जगह 102 यूनिट 102 यूनिट्स जनरेट कर रहा है, देन योर बिल्डिंग वुड बी नेट पॉजिटिव एनर्जी बिल्डिंग. That is not only with the solar part, that can be integrated with any of the renewable like geothermal, like biomass, like the solar panels, like the windmills, like the hydro, any type of renewable systems that are incorporated in the building. If it increasing and generating more than the required for building operation, it is net positive. And that all systems building operation, if it is equivalent to the energy requirement, it is net zero. If it's generating more, it is net positive. So these are the simple definition. How you can see these are, we are changing and we are increasing our ideal case. Nearby zero buildings, basic case. From bottom to top, how we are converting to red to green, red to yellow to white to green and to dark green. Nearby zero buildings, net zero energy buildings, positive energy buildings, all energy positive buildings, and zero energy footprint buildings. So zero energy footprint is also includes the carbon footprint. Net positive I have explained you is one that an average over the year produce more energy from renewable energy than it imports from the external resources. If it importing from the grid, अगर आपने 100 यूनिट जनरेट लिया और आपकी 120 यूनिट्स की रिक्वायरमेंट है, देन 120 की जगह आपका सोलर और रिन्यूएबल 125 एनर्जी यूनिट जनरेट कर रहा है, देन योर बिल्डिंग वुड बी नेट पॉजिटिव एनर्जी बिल्डिंग. So there is a power of net zero to positive. You can see the buildings like this, the plants, the trees, the facades, like the shading part. You can see the glass. There is a limited use of glass, and the complete facade is covered with a green area. And for developers, it is the net positive sustainability strategies lies in accurately defining each property's electricity use, water use, carbon use, and then setting the short term and long term goals for reducing negative impact and promoting positive impact of your building. This one line describe your power of net zero to positive. This is one such example. Rochester Institute of Technologies, New York. So very few buildings that have been constructed in India which are net zero and net positive. I'll show you some example in my upcoming slides. But here, when we are discussing about net zero to net positive, the what is the power? The Rochester Institute of Technology. It is located at New York. This building you can see how the building facade, how the glass part, how the greenery, how the shading and all such equipments which are using double glaze, which are using the glass and the cavity wall with insulation. And roof is also integrated with solar panels. And roof is also providing shading to your upper glass, which is covered by the building. You can see here high performance design and building energy system. So from starting from here, they have integrated the solar PV panels. They have accessible vegetated green roof. They have solar shading devices. They have geothermal well filled, geothermal that have low energy cooling systems. So some of the floors they have used radiant cooling systems. They have used rain garden rainwater for capture and reuse, rainwater harvesting. This is the electric vehicle charging station. They have used battery storage system, energy recovery and heat capture. So these are all such types of parameters that have been incorporated, and these are all incorporated, can be incorporated in the existing buildings as well, so that we can convert our existing building to the green building, to the net zero, to the net positive building. So these are some of the buildings like this. Building construction, wall and roof, cavity with insulation, optimum use of glass, glass double glaze, glass with shaded area, complete roof is covered with the solar panels and with a shading device. The building is Bullet Center, which is at Seattle, Washington. So they are creating the benchmarks. They are providing support to us, and they are providing guidance how we can create our net zero to net positive. Another such example, which is the one of the finest world's green building in five top world five top five world's rated green buildings in the world. This is one of the top five rated buildings, which is Powerhouse Zorbo. It is at Oslo, Norway. Powerhouse Zorbo. You can see the building design, how the sides area have been covered by the trees and green area, how it can be covered, how the building design is there, use of glass, the building materials, right? The integration of the technologies, all such latest technologies like BMS, lighting LEDs, five-star rated, geothermal systems, radiant cooling system. They all have been incorporated in one building, and they are providing a showcase. Few of the climate responsive, I would like to show you. This is one such example from our climatic condition, human spaces. So you can see the roof, the dome-based roof, which provides lesser heat to come in. You can see the design, you can see the glass area, Why we are converting such architecture to the Western architecture? These are some trees around us which also provide shading to our spaces. These are the open spaces which also provides you and connects you with the nature. When there is a cool air, fresh air, it's around with the, and it was cleaned with the fresh air, with the greenery part, with the uh, landscaping part that we need to integrate. Another is example I would like to show you. This is one such example which I touched when I researched on the net zero to positive building. I came across this building, which is the net zero, the road to net zero to positive. They have showed a create a benchmark. They have showed example. National Renewable Energy Laboratory, NREL Research Supports Facility, which is located at Golden, Colorado, USA. I'm sure all of you are aware about NREL, Renewable Energy Laboratory. So they have a support facilities building have been designed and constructed. You can see the design, artistic view. They have created a sustainable high performance design, energy efficiency they have integrated. They have integrated high performance commercial buildings, right? So these are all such types of the parameters that we need to integrate, and the design and location is providing a benchmark. Why performance based design build works? Performance based design, performance based building construction, and performance based implementation that I have discussed you and mentioned you in the initial slides, so that you can encourage the innovation. How you are creating innovation? What is the faster construction and delivery? What is the better cost control and establish major success criteria? Focused on the energy building, which is also performance based approach. All buildings, they have not only created the design, they have created life cycle costing of the building. So this is one such example developing a performance based. So tier one, you can see they have mission to attain a safe work and design. Safety and security is first. After that, yeah, hello. Yes, the mission, which is critical goals, is firstly to attain a safe work, design work. Lead Platinum and Energy Star Plus, this is a tier one mission they have. Tier two, you can see the highly desirable goals. Tier three, you can see if possible goals. In if possible, you can see they have vision to create net zero. They have vision to create most energy efficient building in the world. They have vision to create lead platinum. They have create to achieve national and global recognition and award. First day, they have visual and they have vision to create performance based approach of buildings. So this is completely touched you. So they have focused on energy efficiency features. Secondly, they add on renewable energy systems in the building, and they add on energy performance requirements with the extensive building energy modeling. That is the whole building simulation approach. How you are designing, how you are putting the glass, what glass you are putting, how much total energy your building will be consumed. Everything that have been covered, and it was at the initial planning and design of the building. They have created energy modeling, they have done the energy use breakdown, they have the major space heating. Major consumption is over the space heating, because that area is cool area, because Colorado is one of the coldest space in the world. So they require space heating and the data center equipments, because all data center equipments required more air conditioning to operate. So they have space heating, space cooling, pumps, ventilation fans, domestic hot water, exterior light, interior light, everything that have been covered is respect of lighting, heating, ventilation, domestic hot waters, and data center fan and cooling systems. So you can see the design here, optimal orientation they have put. They have put high performance lighting. They have put insulated precast wall panels. They have put windows, operable windows for natural ventilation. Try to use operable windows for natural ventilation. So aggressive plug load control strategy and rooftop and parking load solar based PV system they have incorporated in the building so that your building is one of the net zero. The vision is to create one of the net zero building in the world. So back to the future, you can see the design. You can see here the glass. They have put complete glass shading where there is a complete glass and where there is a complete solar radiation which are impacting to the glass. So they have put the solar shading device over it. Here it is. They have put glass over here where there is no much impact on the solar heat gain. They have put daylighting. They have focused on thermal mass, which is building envelope, wall and roof. They have focused on natural ventilation, and you can see the building here. Complete building where the glass is directly impacting. They have put the shading devices. They have put recessed windows, complete solar panels over it, complete buildings for facade building and daylighting they have used. This is the lowers, the fixed lowers they have used so that they can capture the natural light, but it restrict the solar heat gain, limit excess light and the glare. It will also provide limit the uh, excessive light that is coming from outside, and it will reduce the glare also. Thermal mass you can see here, cavity wall you can see here, external external wooden blocks with the glass wool or rock wool insulation, and then is the pre-insulated cast panel. So you can see here the natural ventilation, and there is openable window you have. You can open the windows and you can allow the fresh air, cool air to come inside the building, and your building would be naturally ventilated. So you can see here the triple glazed glass with individual overhangs they have used to capture maximum daylight and minimum glass. This is one such example. You are really amazing from the design, from the planning stage to the construction to the implementation. One of the best buildings. You can see here the shading with the solar, complete shading facade over the solar panels over it. These are the solar panel here. One roof is 1146, 418, 450. You can see here how the electricity is being generated by them. Why energy consumed by the space here? The energy, basically energy moving. So energy consumed is by the space heating. Energy consumed is by the basically data center equipments. So this is how we are generating the energy. This is how we are generating the energy. This is how we are getting solar renewable solar renewable based systems. So you can see here what was the electricity at that time when the building was designed and in planning. It was using 3,99,000 electricity consumption, and when it was designed and integrated with solar panels, it was just only the total cost of the electricity is 77,263 rupees. You can compare it with the rupees only, because this is one such example from the outside USA, and this building is consuming and paid in the US dollars. If you can compare it here, like if you are giving to the authority, and if you can design a building like that and integrate with solar PV, your only electricity cost of an year would be 77,000 rupees, which is 81% reduction in power generation. So this is one such example. This is a small building adjacent to the mountains, covered to the green, small improvements, big difference that we see over. Small improvement that creates a big difference is also in the monitoring part. They early data. They are improving early mechanical ventilation, early heating, early cooling, every type, every water use, early energy use, every something will be maintained by the meter metering system they have installed in their first. Now I would like to show some of the case studies that is from India. So this is one such example from Visa, which is located at Ludhiana. Ludhiana from Punjab. So this is architecture design architecture, and this building is educational institute. Scientists are building very beautifully designed. Double glazed glass they have put. They have put cavity wall with insulation. So this is a visa area. You can see here how much percentage energy they have saved. Around 50% energy they are saving. And we have, this is one such ECBC compliant. This is also one such a green building. So yeah, this is one building. So you can see here energy consumption. If around 1,000 units in consumption, around 492 is being consumed by the actual case in building that is constructed, completely constructed. Around 50% is being saved in this building, right? So one is the another Indra Paryavaran Bhavan. It is located at New Delhi. So this is one such example from MOEF, Ministry of Environment and Forest. This building have been designed by some architect from Delhi, and this is constructed by CPWD, Central Public Work Department. This is an example from Indra Prevan Bhavan. You can see here the orientation part. All glass are double glass. You can see the solar panels. You can see the roof area, how the roof area have been integrated with solar panels. They are providing shading to the top layer of the walls and to top layer of the glass. Shading by the trees, ventilation, proper ventilation in the O3 area. Indian Habitat Center, which is again Griha 5-star rated building, and beautifully designed, where national and international conferences are being held in the country, right? So this is one such example. Indian Habitat Center, Griha 5-star. So this is how we can integrate in the building. We can integrate such design. We can take it reference from here. And one such example I would like to share it with the Zangezadi Kartarpur. It is located at Punjab. Beautifully designed, great design by a great architect based out at Delhi only. So you can see here they have designed in the building and for the wall cavity wall with fly ash with insulation. For the building envelope with roof, they have integrated heat reflective tiles plus RCC plus lower deck insulation and the fall ceiling they have used. This is from top to bottom. From the glass, double glazed glass plus UPVC frames, HVAC VRV systems, electrical LED lighting, sensor based systems, transformer 5-star, cabling and power factor 0.96, auditorium proper acoustic, metering and monitoring BMS based, This is one such building, PEDA building, completely using all natural resources, natural air, natural sun by using solar PV at the atrium and generating electricity, natural light they are capturing from the environment, and natural layer, so that they have reduced more than 70% of the more than 70% of the air conditioning requirement of the building. So all completely based on natural resources. This is one such B 5-star rated building. Hareda building. This is a 5-star rated building. Complete atrium area is covered with the complete atrium area is covered with, yeah, yeah. So complete atrium area is covered with the misting solutions. You can see the design here. You can see the design. You can see the outer glass, double glazed glass. You can see the solar PV panels that have been integrated over the roof, and they have used VRV systems. Double cavity wall with insulation, with AAC blocks have been used, and with the external glass, so that outside solar gain should not directly inside interior part of the building. So way forward, this is all such example I have showed you. So this is a great vision we all have, to the green, to net zero, to net positive. Do follow integrated design approach. The owner, the architects, consultant and implementers shall start implementation at the initial first day. When you're planning first day, you have a vision, you must have a vision, you must have a technology integrated, you must have a design integration. Then accordingly the construction will be integrated, and your building would be definitely sustainable design with integration of renewable energy systems to achieve net zero and net positive energy buildings, which is also climate responsive. The futuristic building that we are looking for, these are all such where all communities, below there is a mall and above there is a complete community we are living upon. Because when everything is goes digital, everything is located within a 1 kilometer of everything, when all materials of building construction will be used by the locally available materials, locally available labors, when the building would be constructed in such a way, and all of your technology, all of your daily needs would be offsetted by the building itself. Your design, your integration, your all such visible light from outside, that also you must be connected with the nature, so that your productivity be maximum. These are all such type of futuristic buildings which can also provide shading, also use natural light, also use the uh, cavity walls, everything they are using and provide shading to the below part. Also, let's learn from the past. So, like Hawa Mahal, Taj Mahal, and the Charminar at Hyderabad, every uh, historical monuments that have been designed and constructed in such a way that 100 years ago that building have been constructed, and even at that day, today, if you are going at this place, you will feel comfortable even without the air conditioner. You will see the technology that have been integrated 150 years, 100 years back, and how it can be incorporated in our buildings, so that we can build a more sustainable built environment. The objective is to create, to save our planet and to create more energy efficient and green buildings. Summer season is coming up, so and it is running. So set AC at 24 degree. Take place by today, because it is also a running campaign by Ministry of Power to set AC at 24, so that your room temperature must be in thermal comfort requirement. It must not be like that. That is the chilled condition temperature. You are setting it at the room temperature. So 24 degree at room temperature, you can save it around 24 degrees Celsius, and even by 1 degree rise in up to 24, you can save every 6 degree 6% saving in electricity and rise of every 1 degree. अगर आप 24 की जगह 25 डिग्री कर देते हैं तो आप हर डिग्री टेम्परेचर पे 6% ऑफ इलेक्ट्रिसिटी यू कैन सेव. सो टेक प्लेज टुडे एंड टारगेट इज टू रिड्यूस द एनर्जी कंजप्शन and to meet with the sustainable development goals, which are in addition to the sustainable energy, low flow water fixtures, reduce storm water runoff, and solar panel installations. In addition to it, vehicle charging station, that is also coming up, is the new era, electric vehicles. So you need to have vehicle charging stations. So this is all such points that have been incorporated, and this is a way forward to create a sustainable built environment that let's all work together a healthier environment as well for our future generation. And be responsible. The earth doesn't belong to us, we belong to the earth. Save earth, save life, and save planet. The future end with us. Thank you very much. Over
Thank
to you,
you.
Gurneet ji. Yeah,
Yeah.
please proceed.
Yeah. Thank you, Manish sir. It was very informative session, and I hope everybody who has attended this session would have got to learn a lot of things. There were a lot of points which were discussed, a lot of examples given, and this whole was very knowledgeable. So there are certain questions which have come up on YouTube and Zoom channel. So I'll just go through the questions one by one. So you
Okay.
can just, yeah. First question is uh, somebody from YouTube. They say material may be consuming less energy at the site, but on the contrary, it's expensive. The materials which are used for the green buildings.
No, that all material that I have already discussed, they have embodied energy. Embodied energy is at the time when the materials are being produced, and when it is incorporated at the site, it is using less labor, less material, and less upper surface requirements to create it a better vision, so that outer heat gain should be the minimum. So that is the vision, and it will also reduce your energy consumption in a way that your energy, embodied energy, is less, your construction energy is less, and time is also less. And further, when it is implemented, your operational cost and operational energy is also less. So this is how we are integrated energy efficient materials in the building.
Okay. So another question, it is not a question, but a statement that please put some light on the tax incentives for green buildings, or if
Yeah.
any incentives are available for residential buildings as
Yeah, that I've already discussed. That is a very good point. So for the commercial buildings, yes, there is a 5% extra FAR if you are constructing ECBC. ECBC is a mandatory approach, which is also enforced by the government. They are providing 15% rebate on property tax. There is a first incentive. If you are constructing green building, this is again a voluntary approach. If you are constructing green building, that the four rating system, IGBC, GRIHA, GEM, and the USGBC, there are four rating system. If you can construct the green building, you will get 5% to 15% extra FAR depending upon the state to state. Like in Punjab, there is a 5% extra FAR. In Haryana, there is a 5 to 15% extra FAR if you can achieve a green building. So for the residential building, as of now, there is not such incentives are there. But yes, very soon residential building incentive will also be awarded by the government.
well. Okay. Then it is from Uttam KR Saxena, which they say, कि, does green building takes into consideration the seismic zones also?
Yeah, every type of zone, like in India, I've already mentioned five types of different climatic conditions. Five types of zones are in India: cold, composite, temperate, hot and dry, and warm and humid. So it also covers every type of climatic condition. Yes.
Right. So One question is from Mr. Sandeep Singh. They say, can you tell about VRV systems adopted in HVAC?
Yes, VRV system that I already mentioned. VRV is variable refrigerant volume. VRV, variable refrigerant volume, or VRF, variable refrigerant flow. So these are the systems which can integrated. This is a large part of the split air conditioner basically. अगर आप
Hmm.
सिंपल में इसको समझते हैं, that is a large part. If there is a split system, a single room air conditioner, when there is a one indoor and one outdoor. In a VRV system, that is a one indoor for 30 rooms, for 30 indoors, one outdoor for 20 indoors, one outdoor for 10 indoors. That can be designed in such a way so that one outdoor system, one outdoor unit can be integrated with more than 30 indoor units, so that you can also integrate it with automatic sensors. When everyone is is in the room, the air conditioner will automatically turned on, and when there is no in the room, the air conditioner will automatically switched off. So this is how we can integrate such technologies in VRV or VRF system,
Okay. One last
which is
question, sir.
around 1 lakh or 2 lakh square feet. Yeah.
I'm sorry. Yeah, one last question from Irvin Dhingra. They say, how to convert an existing building to green or net zero building?
Yes, that is another good question, and I have already described. This is my the presentation basically.
Hmm.
So when you have an existing building, you have to have that is operated by the energy auditor. So first you need to have energy auditor on your board, so that they will have a conduct walkthrough audit and prepare the detailed analysis report in respect of electrical, lighting, and air conditioning system. Everything from the metering, meter to the main subdivision board to the end user where the electricity is being consumed. So from top to end, every top-down analysis is being carried out by the energy auditor, and then all the measures will be integrated as per the recommendation. Like if you have lighting which are old, you need to replace with the LEDs. If you have not automatic sensor installed, you need to have installed. If there are inefficient fans installed, you need to replace with super efficient fan. If there are non-efficient air conditioner, you need to replace with five-star air conditioner or inverter air conditioner or dual inverter air conditioner, which are consuming less energy. If there is a single glaze glass and there is no shading devices, you need to put shading devices like windows, overhangs, and the vertical pins you can integrate. So there are more such types of interventions than can be carried out in the existing building, so that we can convert it to green building or a net zero energy building.
Okay. Sir, I have one question from my end, and then we'll
Right,
wrap up this.
right.
Uh, we construct buildings, we construct institutes, and as you said, like by 2030, they'll every building will come under the green building, uh,
Yeah, net
green
zero
buildings. Yeah,
vision.
net zero
Yeah,
grid, efficient net zero green building.
yeah.
So, how should we go about? Should we see there's a construction which is going on, and it is around maybe 60% done,
Yeah.
and this is the new recommendation which has come from the ECBC, and
Yeah.
yeah, and so how to go ahead with this? So,
So yeah,
we,
basic. Yeah.
so where we should approach? Where should we approach to PEDA? Where should we approach to ASHRAE? Should we approach
No,
to?
nothing. I'm not sure, because what I have mentioned is a way forward. A way forward is first is to create a integrated team approach. So
Hmm,
see here, integrated design approach means when an owner, architect, and consultant and all implementers like the contractors and everyone, when we all join hands and can sit around a table, we can we can change ideas, we can sit as a green consultant, we can sit together and provide you the inputs that can be incorporated, and the all the things that I have already mentioned and then discussed during this presentation that how we can integrate all such types of parameters like the building materials related to building envelope, lighting, air conditioner, renewable energy system. Because if the building is constructed, मान लीजिए 60% has been done, but still 40% construction is yet to be completed. So yeah, that 40% construction is being done with the air conditioning part and the lighting part. And that 40% construction is also done with the integration of energy efficient roof. So you can create a roof structure which is also integrated with the insulation. You can put the heat reflective tiles over the roof or the solar panels integration. In addition to it, all the equipments are coming up, like you need to integrate lighting, you need to integrate sensors, you need to integrate air conditioner, because when the construction will be completed, you will need to install all our equipments in the building, so that you need to first have the green consultant or all consultant. Yeah, you need to prepare your sustainable design. You need to consult with the sustainable consultant like design consultants, and then we can join hands and came across on the board so that we can put it on the table and can incorporate all energy efficient and green features in our building, so that our buildings would be definitely a green building and net zero and net positive.
Thank
Because
you,
when
sir.
you will design, consultant will not sure how many interventions you have done. So what consultant have been provided as a contractor, what they need to provide, that is not sure, because they need to provide the specifications only. अगर मान लीजिए आपकी बिल्डिंग में पहले अगर आप कन्वेंशनल बिल्डिंग बना रहे थे, तो आपके 500 टन का एयर कंडीशनिंग लगना था, अराउंड 500 टन. अगर आप एक मॉल बना रहे हैं, लेट अस सपोज, तो मॉल में आपके 500 टन का एयर कंडीशनिंग था, और आप कन्वेंशनल बिल्डिंग बना रहे थे, और आपने 60% बिल्डिंग बना ली. आपकी 5 फ्लोर्स की बिल्डिंग थी, 3 फ्लोर्स की बिल्डिंग बन चुकी. लेकिन अब आपने क्या करना है, जब आप बैठेंगे साथ में सभी के, यू एज एन आर्किटेक्ट, वी बीइंग एन कंसल्टेंट एंड अनदर बीइंग द कंट्रैक्टर्स, व्हेन वी ऑल सिट टुगेदर ऑन टेबल, we'll exchange ideas what we can do here. We can do here, we need to install 2 floors as well now, fourth floor, fifth floor. For fourth floor we'll complete it like that. We have completed 3 floors. जैसे 3 फ्लोर बनाए वैसे ही फोर्थ बनाएंगे, बट जब हम फिफ्थ फ्लोर बनाएंगे, तब हम उसकी जो एक्सपोज्ड रूफ होगी, हम उसको इंसुलेटेड रूफ बनाएंगे. हम उसे फॉल सीलिंग के साथ इंटीग्रेट करेंगे. हम सबसे ऊपर व्हाइट टाइल या व्हाइट पेंट लगाएंगे, जिससे क्या होगा, जो सोलर रेडिएशन आएंगी, वो मोर देन 90% सोलर रेडिएशन will reflect back to the environment, right? So that is integrated. After that we will discuss, if we have budget, then we can integrate this renewable energy system. If we have roof available, if we have unshaded area available, unshaded area is available, then we can integrate solar PV panels. After that, when the building envelope is completed, then we comes on the glass. So glass part we can construct it double glazed glass, and we can also integrate with the north and the east part. We can cover single glaze to cover the costing, to cover the building economics as well. So हमने जब क्लास लगाना चाहा, तो हमने नॉर्थ और ईस्ट पे सिंगल ग्लास लगा दिया, और साउथ और वेस्ट पे हमने डबल ग्लास लगा दिया, और डबल ग्लास के ऊपर शेडिंग डिवाइसेस भी लगा दी, जिससे क्या होगा, साउथ और वेस्ट पे ज्यादा हीट आती है, और वहां पे ही हमने कम कर दी. उसके बाद क्या करेंगे, हमने जो सारी चीजें लगाई, इंसुलेशन लगाया, सोलर पैनल लगाए, और वॉल में भी इंसुलेशन ऐड करी, डबल ग्लास लगाया, तो बाहर की हीट हमारी बिल्डिंग में कम आ गई. जितनी हमने कॉस्ट इन सारी चीजों को लगाने में लगाई, तो हमारी एयर कंडीशनिंग की जो लोड है, दैट विल ऑटोमेटिकली रिड्यूस टू 500 से 300 टन. So that will save around 200 tons of air conditioning. So that where you will save the costing as well, and you will integrate air conditioner at an optimum time of utilization. आपने वहां पे एयर कंडीशनिंग भी लगाया, थर्मल कंफर्ट भी मीट किया, आपने एनर्जी भी कम यूज करी और कॉस्ट भी कम यूज करी, और जो आपने जितनी जहां ज्यादा लगाई थी, वो आपने कंपनसेट कर ली. सो जैसे आपकी ये सारी बिल्डिंग बनेगी, ओवरऑल आपकी कॉस्ट 1 रुपया बिल्डिंग की बढ़ेगी नहीं, और आपकी जो पूरी बिल्डिंग है वो ग्रीन बिल्डिंग और नेट जीरो बिल्डिंग में ऑटोमेटिकली कन्वर्ट हो जाएगी. दिस इज द कंप्लीट विजन टुवर्ड्स इट.
Right, sir.
थैंक यू
Right.
वेरी मच. या
Thank you, sir. Thank you for all your knowledge, information. And now I would like to thank IIA Punjab chapter. I would like to thank Aishwarya Chandigarh chapter and Jim for supporting us for this session. Thank you everyone for attending this session. Thanks a lot.
थैंक यू वेरी मच. थैंक यू वेरी मच.